Hello and welcome to my talk on DigitalOcean Deploy. I'm super stoked to be here. I'll be talking about Corona Status, an open source web app that we built during the Corona outbreak. It's an open source web app that lets anyone anonymously self-report symptoms of COVID-19. In this talk, I'll be going through how we built it, the choices that we made, how we built a small community around the open source initiative that drove the development, and also our experience with how this was being hosted on top of DigitalOcean's infrastructure. So I hope you enjoy it. First, I'll try to show you how Corona Status works. So, like I mentioned, it's an open source website that lets you anonymously self-report COVID-19 symptoms. So, what you do is you go to coronastatus.no in my case, because I'm in Norway, but there are 30 other countries where you can also self-report. You choose the language that you prefer to have the site in. So I'll do it in English for now. So it starts off in the heading here with a bit of information on how this works and why we built Corona Status. I won't go through that now. And if you scroll down here on the page, you'll actually see right off the bat how many reports we've collected. So these are the Norwegian numbers. So we have 7,500 total reports. We have 34 infected over 269 that report that they have been tested, 284 that have been in close contact with someone who has been infected, and then we have more than half, 4,396, that report that they have symptoms. And all of this is anonymous. So what you do here is you fill out this form. You're first asked a couple of questions about your demography and geography. So your age, I'll fill this out. So I'll put 20 to 29. I'm a male. I'll put in a post number. And then I'm asked if I've been in close contact with someone who's tested positive. No, not that I know of. If I have been tested for COVID-19, and I have not. Any symptoms I'm experiencing. And these are taken actually from a research paper on COVID-19, but I'm not luckily experiencing any of these symptoms. Have you been diagnosed with any of the following conditions? No, I have not. And I'm currently not in isolation because I'm not sick. I do not smoke. What is your current body temperature in Celsius? Here I'm going to go ahead and guess 37 Celsius. And finally, I get asked a couple of questions on data and privacy. So in order to submit your report, you have to agree that the data is open source and available to anyone. There's also a privacy statement that you can read here. And you can also optionally set a cookie in your browser so that we remember your browser the next time you come around. This is in case your health condition changes, so that we can have more accurate reports on how people are progressing. So I'll check this, but this is totally optional. And when you submit the report, you'll be told that we've stored the cookie in your browser. So you can simply revisit the website if you want to do that. Or you can manually write down this URL in case you don't want to have a cookie. So if we press proceed here, we ask you to share the link on social media to anyone else, because the whole point of Corona Status is to gather and crowdsource data. So that only works if a lot of people are submitting information. So that's optional, of course. And what's cool about this is that when we've gathered enough data, we can start to visualize that data. So we have this one visualization, which is on a map. So here I'll be zooming in to where I live, and I can also explore how the capital of Norway is doing. So if I zoom in here, I can look at these circles, and these circles, they represent how many have reported that they have symptoms, how many, and the red part of the circle is representing how many have tested positive for COVID, and the green part of the circle are reports that indicate that they are healthy. So this kind of gives you a very rough overview of how COVID-19 is spreading where you live. Now, coronastatus.no, it will only show you data for Norway, but you're of course free to explore all the other websites that we also have. Moving on, we also have a statistics page, and this page tries to aggregate all the reports that we've collected into some helpful charts. So here we show the same thing that was displayed in the map, but a bit differently. So how many have tested positive to how many are waiting for a result, and so on. We have some key figures, and also how many reports that have been submitted. We also have a change log to the form so that people can know if we made any changes to the symptoms that we classify as COVID-19. And then finally here, we have an API. So with this API, anyone can build apps on top of the data that's been collected. So you can export it, or you can build something that visualizes it in a better way than what we have done with the website. So I work for a small consultancy based in Oslo, Norway, called Bustbyte. And what we usually do at Bustbyte is we help other businesses build software. So anything from banking software to hotel software and mobile apps to web apps. That's what we usually do. But sometimes we get ideas that we want to experiment with and prototype. And when the number of cases of COVID-19 were growing at an almost exponential rate in Norway, we thought to ourselves that, there could be a digital solution in trying to figure out how many were actually contracting this virus. It was quite obvious to us that testing at that scale, medical tests that is, was just not doable. So Coronastatus was our attempt to try to solve this digitally. So the first version of Coronastatus was actually very simple. We used just plain old static HTML to build a form that people could fill out. That form was then processed by a Node.js app on the backend, and the form submissions were dumped to a SQLite database on disk. So this was not fancy at all. What was advantageous about this setup was that it was so simple, so it was easy to move fast and iterate on top of it. So from having the idea of building Coronastatus to actually deploying it on DigitalOcean and having it up and running took like 4 hours. So while we were building Coronastatus, we tried to make a conscious effort in spreading the word and getting other people involved. So we tried to tweet and ask people if they were interested in deploying the same site in their own countries. Because it turns out that the idea of building a self-report website was not a unique idea at all. People were actually building similar sites all over the world. So we were quite surprised to see that there was a lot of interest on Twitter. So people were retweeting links to the project, and it was just a pile-on of developers from all over the world who wanted to join. What was also pretty helpful was that GitHub has a trending page that shows repositories that receive a lot of, I think, visitors and stars and pull requests. And they actually featured Coronastatus, which I think also just helped accelerate this really huge growth of people wanting to help out and deploy versions in their own country. After opening the floodgates from social media, we needed a way to communicate with all these developers and coordinate our efforts. So we started a Telegram chat that anyone who wanted to could join. So what people did was they joined this chat, and then they wrote how they could help, what kind of skills they had, and even if they wanted to deploy a new version of the site in their country. That's where we coordinated all of that from. And what was also very cool to see was that people who ran small online businesses, such as Simple Analytics, chimed in to let us know that we could use their services for free across all these Corona status sites. So Simple Analytics that I just mentioned is a GDPR compliant analytics tool that functions as an alternative to services such as Google Analytics. So that was very helpful. And we also got Stadia Maps, which is an alternative to Google Maps, to give us API keys that we could use across all these sites. So not only were people helping out with their free time, but we were also getting a bunch of help from people who were willing to sponsor us with software. As the number of developers who were joining the Telegram chat grew, so did the number of countries we were deploying Corona status to. This was due to people wanting to spin up Corona status sites in their own country. So what we did was we applied for DigitalOcean's Hub for Good program to get credits so that we could sponsor these sites and the cost associated with them. So luckily we were accepted, and that was great because that really lowered the barrier for people to be able to host these sites in their own countries. One problem that we ran into was managing this, like from an operational perspective, because we were now running 30 different droplets, one droplet per country, and this was getting very difficult to manage because every time we wanted to release a new version or upgrade the software we were running on any of these droplets, we had to manually SSH into the machine, restart any services, do upgrades, almost pray that nothing broke, and then hopefully then just resume development. So this was very obviously not scaling well as we were adding more and more sites. So we started to look into alternative ways of hosting it, and DigitalOcean's Kubernetes offering was perfect. The way we set this up in DigitalOcean's Kubernetes offering was that we had GitHub as our source control management system. This is where anyone who wanted to contribute would submit pull requests, which are essentially changes to the code base. And whenever they did that, we would have a workflow in something called GitHub Actions automatically execute a test suite to check that the changes didn't break any existing functionality. So this was a really nice and automatic way of filtering out anything that we shouldn't ship. And this was super important because we were running, like I said, 30 websites, and it was just not scalable checking this manually. So after successfully passing the test suite, we would bundle or create a build of the source code and ship it as a Docker image to a container registry called Docker Hub, which is a public container registry you can use for public projects. So after deploying a new version to Docker Hub, we would then instruct our Kubernetes cluster in DigitalOcean to pull down the latest version whenever we wanted to deploy something new. So the way this works, as you can see in the diagram, was that we would have public internet traffic come in and hit the load balancer in DigitalOcean. And then that would then round robin the traffic around to the different services inside of the cluster. So we would basically have an Nginx ingress on top that would receive the traffic and then delegate that to the service, which then again would be routed to the different pods. So in our case, we ran 2 replicas per country, which is to say two pods were at any given point in time receiving traffic or ready to receive traffic. So one important thing in this transition from Droplets to DigitalOcean's Kubernetes cluster was that we could no longer use SQLite as our database. The file system in Kubernetes is ephemeral, which is to say that it's not persistent. Whenever a pod dies, you lose whatever change you had done to the file system. So this is obviously not compatible with SQLite, which is a file system based database. So what we had to do was rewrite the application to use Postgres instead. So we landed on Postgres because it was already SQL. So it was fairly easy to translate the SQLite schema into a Postgres 11 compatible schema. And it was also living inside its own process, not on the file system, which made it work inside of the Kubernetes universe. So before we did the transition from Droplets over to Kubernetes, we had to manage all these virtual machines or Droplets manually. Now, there are of course tools that automate this process, but we were moving pretty fast and we simply hadn't spent a lot of time setting up infrastructure using Ansible or Chef. So we just managed these machines using plain old SSH sessions. So what I'll show you now is how we set this up on Droplets before we had even thought about using the DigitalOcean's Kubernetes service. So here I'll SSH into one of the sites. So this is how we used to do it. Hopefully if I have Wi-Fi. And as you can see, this is just a plain old Ubuntu 1804 LTS operating system. And if we take a look into the Nginx configuration or sites directory, we'll see here that we had one dev website and one production website. So the production website is where we actually serve the application. So here you can see that we had just a pretty plain reverse proxy configuration. So we proxied all the requests back to a Node.js app running on the machine. Yeah, so that's fairly simple. And if I go into the server directory and into the actual Coronastatus app, we'll see here that we are running a Node.js web server that receives these proxied requests. Now, this is all good and nice, but it's really a pain when you have 30 of these machines. Because whenever you do an upgrade, you really have to make sure that all these machines are in the same state. And with a lot of developers working on this code base, that was not always easy. So when we transitioned over to Kubernetes, what we found was that instead of having to manually and kind of procedurally execute commands on these machines, we could instead descriptively come up with a config or a manifest that just explained to Kubernetes how we wanted our apps to work. So now I'll show you that. So this is the repository, and if I go into the ops directory here and into the K8s, we can take a look at the apps. So we have one file here per country, and if I open up the Norwegian manifest, what we'll see here is that we have a deployment that's called Norway that has 2 replicas, which is 2 pods basically. We have a couple of environment variables and a database or a connection string to the Postgres database, because we can no longer use SQLite. We have a service, and we also have ingress. So this would be the equivalent to what you were looking at when I showed you the the Nginx configuration file for the web server. Instead, here we use the Nginx ingress and we describe what domain we would like for the Norwegian site to have. And in case you're hitting the domain with a www in front, we'll rewrite the URL to coronastatus.no and redirect you. So all of these apps are very similar because they're all running Corona Status. So what's really nice about this is that if I go into the, let's say, Spanish site, you'll see that it's almost identical, except of course for the name, but everything else is totally the same. So I can go into a little script that we made. Now I know there are tools for doing this, but this is how we solved it. So we basically just created a small bash script to generate these manifests. So to explain how we do this, we have a template that looks like this. Let's see, where we have this kind of expression of a variable, which we call country name, that we replace, which is then of course replaced with Norway or Spain or wherever the page is hosted. And then we also have a container tag, which is identical for all the sites. So this is kind of a poor man's version of the Kustomize, which is a Kubernetes tool. But we didn't really feel like using that. We were just in business for something simple. So if we go up to the script here and we scroll down, you see that we actually create manifests for each and every country. So in this case, the first argument is the origin, or the URL, if you may, of where you can reach the app. And then we have the country code, which is NO, and we have the name of the country, which is Norway. And this function here will actually drop a manifest inside of the apps directory here. So what you can do after you've added a new line to that script is you can simply say Kubernetes apply f and then given the app's name. And what your Kubernetes client will do is it will take all these manifests and ship it off to the Kubernetes server. And from there, it will try to diff the state the cluster is in with what the manifests contain. And if there is a difference, it will actually apply those changes. So this is a really nice way of working with a lot of machines that are very similar, but have slight differences. And there's no worrying of these machines now becoming or deviating in state, because they're all essentially described through the same manifests. The most important takeaway we want to communicate here is that a lot of people advocate using Kubernetes, for scaling a web app to X amount of users. That really wasn't something we needed, which is why we got away with using SQLite and really simple and easy technologies to begin with. And we never had a bottleneck of too many users trying to access the service, and therefore we had to scale. Instead, what switching from like 30 virtual machines over to Kubernetes did for us was that it freed up a bunch of operational time that we usually spent whenever we needed to deploy a new version. Now we didn't have to check that the servers were in the same state. Now we could simply describe the app and push it out and expect that all of them were behaving exactly the same. And if they weren't, you could easily investigate why that is by looking at the manifests, right? Or because now that was living in source control. This was no longer just in a few heads of the people who took on responsibility of doing operations. So to summarize, we really gained a lot in not having to care about these things. It wasn't so much as scaling in terms of users, it was mostly scaling in terms of operations. And that was really a great realization for us, and something that's maybe perhaps not emphasized enough when we're talking about why you should go for something like Kubernetes. So with that, I want to thank you for hosting me. It's been a pleasure, and I hope you check out the project. And considering it's open source, if you have any contributions or ideas, I hope you visit our GitHub repository on github.com/busbyte/coronastatus. Thank you very much.